Here we're going to have rational expressions, which means that it's something involving ratios or fractions with like denominators. And so that means that all of these denominators that we're given will already match up. So just like when you could add fractions like 1/4 and 2/4, or subtract those, you didn't have to find a least common multiple or anything, or change the fractions in any way to make that happen. Now, problem 1, we'll go ahead and we'll rewrite this as 3n over 12 plus 7n over 12, just like it's in our notes. And since the denominators are already the same, they're shared, so I can just combine 3n and 7n together. And I'm totally comfortable moving this together in the same step and not rewriting it over the same fraction. But if that really would help you as an in-between step, you can show this there. I won't. 10n over 12 can simplify. Both 10 and 12 are divisible by 2, so I will write 5n over 6. That's all you have to do for this first problem and sets of problems. So I have 8x over 6 plus 5x over 6. They both have the same denominator, so I can add 8 and 5 to get 13x. The greatest common factor of 13 and 6 is 1, so I'm simplified there. 13 is a prime number. Do problem 3 on your own, and compare it with me in just a moment. That leaves it as 4x plus 7 over 5 dy. That's done. You can't add 4x and 7 because they're not like terms, so that would be totally simplified. Let's say that this was 4, 8, and this was 4. Then you could simplify by canceling out or factoring out 2. But that problem's totally done. Binomials in the denominator. So here you have something with 2 terms, like x and then 1. So that's why these are binomials in the denominator. But there's nothing crazy challenging about these. So I have 2x over x plus 1. You can probably do these in columns, because I think there'll be enough room. Plus 2 over x plus 1. The denominators, just like before, match up. So I skip a line writing x plus 1 here, and then I'll write 2x plus 2. Now what we're going to see in these is that there might be some simplifying possible, so I can factor out 2 from the top, leaving me with x plus 1. And since this is over x plus 1, these x plus 1's cancel out, and I'm left simply with 2. You don't have to draw a red line. I'm drawing that so that it'll help it stand apart for you. In the next one, we'll rewrite it. 3y plus y squared is over 3 plus y is over 3 plus y. Now, we like things in descending order, but since these match up, it's y plus 3 either way. I'm going to write the denominator as y plus 3. But then I'm going to combine these, and since they're both addition, I don't have to worry about moving negatives or anything. So here's y squared plus 3y. Now, that helps me to see that the numerator has y squared and y, so I can factor y out from the left, onto the left, and write y plus 3. And then this would still be over y plus 3, just like it was. So I can cancel out y plus 3's, and I have a remainder of y. And that's not the right word. I shouldn't use the word remainder there. You can make problem 3 an OYO problem. I'm going to have the answer appear in 5 seconds. Well, after you do a problem like we just did in 1 and 2, you really want it to simplify nicely. So the 3's went away, but I think unless I made a mistake, this is what we got. This is what we got to deal with. So it's 5x plus 1 over 11x plus 3. Oh, and if that happens on a test, let's check something out. Let's say you plugged in a value of like 2 here in your calculator. You could do the same over here and here, and then see what this whole expression gives you. And then if you do the same thing, plugging in 2 here, which is way easier, it would be like 11 over 25, which I think is 0.44. So if you got 0.44 and 0.44 here, you'd be like, oh, cool. I did not make a mistake. It was just a problem that ended up resulting in something different looking from what we had done in all the other ones. So you could find perimeter. Well, find an expression for the perimeter. So they're not saying find the perimeter. Like, so by the end of this problem, it's not like you'd say 22 inches or something. This is just a way for them to work in these rational expressions with like denominators into these problems. So you know how perimeter works. So this isn't happening once, it's happening twice. This isn't happening once, it's happening twice. So you really have 2 choices. Just add these and then double what you get, or you can double it in the meantime. So I think there's a pro and a con to each. The pro is that if you double it at the end, that's easier. The con is that you might forget to double it in the end. So I'm going to risk it and go with just adding them as they are. So here we got 4a plus 5b, so I'm grabbing the top portion, over 3a plus 7b, and to that I'm going to add 2a plus 3b over 3a plus 7b. Well, just like in the other ones, we have the same denominator of 3a plus 7b, and I'll have 4a plus 5b. There's no minus sign to deal with in the right fraction, so I'll write plus 2a plus 3b. And then when I go in and I combine like terms in this step, I look for all the a's, 6a. I look for all the b's, 8b total. And I have 3a plus 7b. From the numerator, I can factor out a 2, leaving me with 3a plus 4b over 3a plus 7b. Now looking at this, nothing's going to cancel out. You cannot do this. They just happen to coincide. But as a final step, don't forget to somehow note that you're doubling this. So maybe like a little arrow times 2 for perimeter, and then just write 4 times the quantity 3a plus 4b over 3a plus 7b. And then we'll box that. So yeah, perimeter getting doubled because it has to take into account all of those sides. I think that I will just put the answer to this one. So treat this as an OYO problem and then check what I get. I got an expression that was 2 times the quantity t plus 1 over t plus 2. This will be the first of 2 videos. The second one will get into subtraction and other things.